For thousands of years, we've gazed at the stars asking one question: are we alone in the universe? This dream has inspired poets and scientists alike. But today it's no longer just poetry. It's a treasure map. NASA has a list, 10 worlds that might hold the answer. 10 planets where the search for extraterrestrial life is happening right now. We begin with one that's literally on our doorstep. Its name is Proxima Centauri b. It orbits the closest star to our sun, just 4.2 light-years away. In cosmic terms, that's not even a neighboring city. It's like a house next door with a fence we can almost see. Think about that. Light from our sun takes just over 4 years to reach it. That's so close it feels almost tangible. And the most astonishing part, we only discovered this world, our nearest potential twin, in August of 2016. It had been there all along, hidden in the glow of its star. But proximity is just the beginning. Computer models, built on the data we've gathered, paint an incredible picture. Proxima b might host liquid water, oceans, rivers, conditions ripe for the emergence of something familiar. Scientists even assigned it a similarity rating to Earth. Imagine a scale from 0 to 100, where 100 represents a perfect twin of our planet. Proxima b scored 87/87. That's one of the highest ratings ever given to an exoplanet. This isn't just a cold rock floating in space. This is a world filled with immense promise. The perfect candidate lies right under our noses. It feels like we hit the jackpot on our very first try. But the cosmos rarely plays by simple rules. A high similarity rating doesn't guarantee a paradise. Sometimes, behind the facade of Earth's twin, there lurks something entirely different, alien, and even hostile. What if those seemingly ideal conditions on paper actually forge a world of extremes, where life clings desperately to a fragile line between eternal ice and searing fire? This world lies just 40 light-years from us, nestled in the constellation of Aquarius. It's called TRAPPIST-1a, and it's a planet with two distinct faces. On one side, an eternal, searing day blazes on. This half is forever locked in position, facing its star, glowing red-hot with no chance for respite. On the opposite side stretches a frozen desert, shrouded in endless night and cosmic chill. It never glimpses its sun. This isn't simply a cycle of day and night. It's a sentence of isolation. A planet frozen in time, much like the moon is to Earth. It experiences tidal locking, forever caught in a gravitational embrace. It may seem impossible for life to exist here. The temperatures are either scorching hot or freezing cold. Yet, life is cunning. It doesn't require the entire world, just a narrow strip of land between these extremes. Scientists call it the Terminator Zone. This zone exists in perpetual twilight. It's a band where starlight grazes the surface, creating a constant dawn or an eternal sunset. Here, temperatures can be just right for liquid water to thrive. Not a realm of rivers and oceans, but a delicate, life-giving line that wraps around our planet. An oasis perched on the border of hell and frigid emptiness. But what if extremes aren't about place, but time? Let's turn our gaze to the planet GJ1061c. For its potential inhabitants, if they exist, our entire week amounts to a single year. This planet completes one full orbit around its star in just 6.7 Earth days. Cycles of birth, growth, and death unfold at a dizzying pace. Whole eras can flash by while seasons change here on Earth. This challenges us to rethink the very essence of life. Imagine beings for whom our hour represents an entire lifetime. It's a puzzle that stretches beyond biology and into the realm of our imagination. These worlds, frozen and swift, scorching and icy, exist. We glimpse their transitions through tools like the Spitzer Space Telescope. They reveal that habitable zones can be far stranger and more extreme than we ever imagined. But passive observation is just the beginning. What if, on the edge of an eternal sunset or in a realm where a year lasts only a week, someone waits? How do we move from mere knowledge to dialogue? How can we shout across the void, sending a signal into the emptiness that says, "You are not alone"? We've already shouted, but this shout wasn't just a sound. It was a beam of pure information fired from a massive radio telescope in 2017. The SETI project shifted from passive listening to active dialogue. We sent a message, a greeting encoded in mathematics and music soaring through the darkness at the speed of light. This is no longer a hypothesis, it's a reality. Humanity has knocked on the door of the cosmos, and now we wait to see if anyone will answer.
Our destination is the rocky planet Luiten b, also known as Gliese 273b. It orbits a quiet red dwarf star. This planet ranks as the fifth closest potentially habitable exoplanet we know of. While it's not the nearest, like Proxima b, it stands out as one of the most promising. We didn't choose this planet by chance. Luiten b offers stability. It sits perfectly within the habitable zone. This candidate appears too good to be just a fluke. Unlike distant anomalies like K272a, which lies 217.1 light-years away, Luiten b is our neighbor on the galactic block. The signal will take just over 12 years to reach its destination. This means it will arrive around 2029, if someone is there to receive it, and if they respond immediately. Their reply will take another 12 years to travel back to us. That's 24 years of silence. But while this signal journeys through the void, scientists aren't sitting idly by. Right now, they are searching for worlds that might even surpass Earth. We call them super-Earths. These planets are more massive than ours, yet still rocky, with stronger gravity that can hold onto a dense, life-sustaining atmosphere. The theory states that three fundamental components are essential for life: liquid water as a solvent, energy from a star, and organic materials. These are the building blocks. But what if we've already discovered worlds where all three components, water, energy, and organic matter, don't just exist but have created the ultimate holy grail, a thriving biosphere? Forget about building blocks, we're talking about complete worlds. Meet TRAPPIST-1d, the ocean planet. This isn't a world with separate seas and continents like ours. Calculations suggest that up to 5% of the planet's mass could be water. 5%. That might not sound like much until you realize that on Earth, water makes up just 0.02% of our mass. That means TRAPPIST-1d contains 250 times more water than all of Earth's oceans combined. Imagine a vast, global, possibly infinitely deep ocean covering its entire surface. This isn't just a theoretical model, it's something much more profound. This world possesses a key element that transforms a hypothesis into a scientific fact: a confirmed atmosphere. NASA sent out telescopes and received a signal. A compact, dense gas envelope wraps around the planet, capable of trapping heat and shielding water from evaporating into space. Water exists. Energy from a star is present. And now there's an atmosphere, a mechanism that preserves it all. 2 out of the 3 essential components for life aren't just assumptions anymore. They're documented realities. This isn't a desperate search for a needle in a haystack. It's an exploration of a concrete, tangible target. But even the ocean planet pales in comparison to our next contender, Kepler 442b. Located 1,200 light-years away, it sits unimaginably far from us. We may never reach it. Yet the very idea that a vibrant world could thrive in such a vast abyss suggests that life in the universe isn't a mere accident. It might be the rule. Researchers confidently assert that this planet offers not just the conditions for life, it likely hosts a biosphere of its own: plants, animals, a complete ecosystem reminiscent of Earth's breathing and evolving trillions of kilometers away from our home. A planet shrouded in a global ocean, a world with a confirmed atmosphere, a distant twin of Earth, potentially boasting a functioning biosphere. This isn't mere fantasy. These are facts. These are the targets for next-generation telescopes. We've uncovered evidence that our boldest dreams can indeed become reality. And if we've already glimpsed such extraordinary worlds through our instruments, what new horizons will reveal themselves when we learn to look even further and with greater clarity? The 10 planets we've explored are just the beginning. They represent only the first page of an endless book. Astronomers have confirmed the existence of over 4,000 worlds beyond our solar system. 4,000. And that number becomes outdated the moment you hear it. Our search has transformed from isolated random discoveries into a relentless conveyor belt of new findings. We've learned to see the invisible, and what we've uncovered exceeds all expectations. But the most astonishing part isn't the sheer number. It's that we're beginning to recognize patterns. We've uncovered the Tigardin star system, one of our 30 closest cosmic neighbors, just 12.5 light-years away. In its habitable zone, more than one planet orbits. In fact, several do. This discovery shifts everything. We were searching for lonely oases in a lifeless desert, and instead we found entire archipelagos of life. Systems where conditions could be suitable on multiple worlds, all circling the same sun. These discoveries transform a faint whisper of hope into a confident hum of anticipation. We stand on the brink of an era where next-generation telescopes will enable us to do more than just map distant worlds. They will allow us to peer into their atmospheres, analyze their chemistry, and search for signs of biological activity. The key question has shifted. It's no longer about whether life exists elsewhere. Now we wonder which of these thousands of discoveries will be the first to provide undeniable proof that we are not alone. The answer is already being written. It forms from every photon of light captured by our telescopes. It hovers near Proxima b, our neighbor beyond the galactic fence. It exists in the delicate line of life on the terminator of TRAPPIST-1e. It pulses in our own signal, racing through the void toward Lytton b, carrying our message. It resides in the vast ocean of TRAPPIST-1d and in the distant, barely detectable breath of Kepler's biosphere. Each of these discoveries marks a step that brings us closer to the greatest moment in history. The search continues, and one day we will know for certain.